Everyone, I got number 22 from chapter 7, which asks, what is the intermediate of this reaction? So here we have a butene reacting with a hydrobromic acid. I think it's just called bromic acid. Hydrobromic acid. Anyways, so let's draw out the compound we have, the reagent we have here, which is HBr. We know bromine is like very electronegative. So even though there's a bond between them, the hydrogen is like very partial positive, meanwhile the bromine is like partial negative. And we know that alkenes, or at least pi bonds, they're very nucleophilic. And this one, because it's not super stable or anything, it's willing to share its electrons with something. And so this pi bond over here, it's going to be attracted to the protein. It's like, hey, I'm willing to share with you. So let's bond. And now the hydrogen is going to go towards the pi bond, and all of the electrons are gonna go towards the bromine, right? But now we're left with a predicament, because this alkene, this pi bond is connected to two carbons, this one and this one. So how do we decide which one it goes towards? Well, if it went to this one here, this will be a stable charge, and then this will have a plus charge, but this plus charge here would only be supported by one carbon. Meanwhile, if it went to this section here, then this side would have a plus charge, and this side would be supported by two carbons, and this one would be stable. So which one do you think is more stable? Oh, well, you can't talk, but if you were able to respond, which one do you think would be able to stabilize more? One that is supported by two carbons, or that is supported by one carbon? Well, the answer is the one that is supported by two carbons. So we're going to have the hydrogen come over here. And now this one is going to be stabilized. Let's pretend that this pi bond isn't there. And then there's going to be a plus charge here. So let's see our options. Well, we know that B is our answer. And then A, we already said why A can't be the answer, and that's because like it'll be more stabilized in between two carbons instead of being by itself supported by only one carbon. So it can't be A. It can't be C nor D because bromine is nucleophilic. The pi bond is nucleophilic. And in chemistry, only opposites attract. The same sides, they don't. They repel each other probably. The second question I got is toluene sulfone chloride reacting with sodium ethoxide. Actually, no. So we have 1, 2, 3, 4, 5. Pentanol reacting with toluene sulfone chloride first, and then afterward it reacts with sodium ethoxide. So a toluene sulfone chloride, the major thing that it does is it converts OHs into good leaving groups. So it converts the OH into an OTS. So let's just redraw it. 1, 2, 3. Wait. 1, 2, 3, 4, 5. This is the Me here. And then the OH, this is bold. And now the OH becomes an OTS. So now that it is a good leaving group, it's going to react with the sodium ethoxide. And since it is a good leaving group, E2 elimination will occur. E2 beta elimination will occur. And so this will leave, right? But remember, whenever we have E2, the beta carbons need to lose a hydrogen. So the beta carbons are here and here. And again, let's see which one would it prefer to choose. The one that is less stable or the one that is more stable? I hope you said the one that is more stable will lose one because, I mean, yeah, the one that is supported by two carbons instead of one carbon because it's more stable, meaning that it can handle it better. So, yeah, they're going to like pluck a hydrogen. Oh, wait, let me do this in a different color. They're going to just pluck a hydrogen away. And now it's gone. And now the alkene is going to form in between. So the OTS is gone and this hydrogen is gone. So let me just redraw it. 1, 2, 3, 4. and then there's going to be a pi bond in between. Now, the reason why I'm not drawing bold or dash anymore is because it's not planar, because it is a pi bond. Yeah, so that is our answer. So that answer that we have here, the most similar, is C. Oh, it's an icon. Okay. Yeah. The reason why it's not E is because the whole point of us adding in the toluene sulfone chloride is to make OH a good leaving group, because OHs are bad leaving groups, you know. They're very they're kind of like strong nucleophiles, strong bases. So we had to convert it into something willing to leave, something that is bulky, that can't be bothered to stay. So it wouldn't substitute because we need to get rid of the OH. And then when the OH turns into an OTS, the OTS just can't be bothered to like change anymore. So there wouldn't be any ethoxide like just swapping places. And then yeah, there's no swapping. And the reason why it's not D is because, again, we're going by stabilization. It'll just be better to stabilize between 2 carbons. Or resonance will also be stronger over here, because here it could go there, it could go here, compared to over here where it could only go here, less places to go. So yeah, that's why C is our answer.